and you look at our aim for today, it says Kipsters will be able to find the rates in a word problem and write it both ways. So that's a very simple aim for the day. We're actually going to be doing a little bit more than that in terms of what we're discussing, but our key takeaway is that we're going to be looking to be able to do this. There will be some things today that we talk about that are really going to be more of a preview and some reasons for you to understand why we're doing this aim today. But the goal is that we're going to be laser focused today on being able to get the rate out of a word problem and be able to write it both ways. All right. So all this discussion about rates, which is the title of this particular unit, rates, etc., we need to know what the word rate means or what a rate is. Is there anybody with some prior knowledge about rates that can describe to me what a rate is? See Kyrie taking a chance here. Kyrie? So one thing that I hear him saying is the word proportion. So a lot of you in the past have solved rate problems or similar types of problems, rates and ratios, with proportions. We are actually not going to do that. I'm going to teach you a completely different skill this year, and it's going to be really important for you to not get stuck on trying to do things with proportions, because there are going to be things that look similar, but it's going to be completely different. And if you try and solve it with proportions, then you're going to get very easily confused. We're going to use something called dimensional analysis to help us identify some different things. I think it's easier than proportions, and the check is a lot easier than proportions as well. So what a rate is. So in the previous problem we were talking about, it was $20 for one CD. A rate is very much like that, in that it is a relationship between two unlike things in which if one thing changes, one thing changes, so does the other. So in the previous problem on the do now, we looked at it and we saw, the amount of money and the amount of CDs. So as you increase the number of CDs that you want to buy, that also increases the amount of money you have to have. Or you could think about it the other way. The more money you have, the more CDs you can buy. And so that's a rate. It's a link between two unlike things. In this case, CDs and money. Yes? So in a lot of different problems, there's going to be a lot of words or phrases that are going to help us identify some rate problems or some relationships between units. I'm just going to make a short list here that we will be adding on to. So we see for each. We might see the phrase for each. We might see the phrase for every. We might see the word per. We might see the word rate or ratio. And we also might see this word or this phrase varies directly with. All of these are going to be indicators that it could possibly be a rate problem. That's not to say that every word problem that has the word for in it is going to be a rate problem. But if we see for giving us a link between two different sets of units, then that might very well be a rate problem. Also doesn't mean that every time that we have a rate problem, one of these words will be in it. Okay? That's not necessarily the way it works. So not every word problem is going to have these words in it, and not every word problem that has these words in it is a rate problem. So we're going to look at some examples today to help identify the rates. You're also going to see down here at the bottom of this problem, it says dimensional analysis. That's the process that we're going to use to solve these types of problems. I'm going to do that for you today, not because I want you to learn it today, but because I want to preview it for you, and because I want you to see where we're going with this. And that should answer the question, why are we doing this today, Mr. Boots? All right. So the question says, Joshua goes online to iTunes to buy some new songs to play at his party next weekend. The price is $1.50 for one song. He needs 15 songs to fill the length of the party. How much will it cost him? So if I'm approaching this problem, the first thing I'm going to do is I'm going to bracket in the question, how much will it cost him? I'm going to go ahead and write my complete answer since.
It will cost.
It will cost. If we're talking about cost, my units here is some sort of money units, which in this case we're doing American dollars. It will cost him blank dollars. So when I was reading this problem, I noticed this word for, and I noticed this rate right here. So I underline that word for, and I'm going to box in that rate. That's a rate. That's a relationship between two different sets of units, dollars and songs. I can write that relationship as a fraction, just like you learned last year, $1.50 for one song. Now what's important here is that that relationship goes both ways. It's $1.50 for one song, or it could also be written as one song costs $1.50. I think I was saying $150 there. That would be a lot for one song. Shh. Okay, so this is a rate problem. We're going to talk about a lot in this unit about different types of rate problems, but this helps us identify that this is a rate problem because we see that rate. We have over here what we call a situation here. So the way that dimensional analysis works, and the reason why I've really focused on the units here in my answer and writing this rate two different ways, is the way dimensional analysis works is by looking at the units and only really paying attention to the units as the guide to what we're supposed to do. So in this particular problem, I know the units of my answer are supposed to be dollars. So I'm setting up my calculation here with my answer having units of dollars.
Is it supposed to be a ratio? No.
So I know that what I'm trying to find out about is 15 songs, so I know that I'm given 15 songs, and I know I need to do something with that 15 songs. The great thing about dimensional analysis is we can use the dimensions, we can use the units, just like we would any other number in a multiplication. Meaning that if we have the same units on top and the same units on bottom, just like any other multiplication, we can cancel them right on out. So here, I see that my current units say that I have songs, but I want my units to be dollars. So I have to think to myself, what can I do? Which of these two rates can I use to help convert my songs to dollars? That's going to cancel out my songs and leave me dollars on top. So when I look at that, I go, oh, well, it looks like this. If I put this in this blank right here, $1.50 over one song, I'm going to be able to cancel out. Just like we would anything else, songs cancels out with songs. Leaving me with my units to be dollars. And so what that tells me is I need to multiply the 15 times the 150. And that's going to leave me with my units dollars. And so a lot of times in the past you did this and you had to remember all this very specific stuff about proportions, and you probably had this long process of checking your proportions. The great thing here is that you already did the check. If you've done your problem like this, you've already done the check. The check was when you canceled out your units and you made sure the correct unit was the unit in your answer. That's all. That's the work here, okay? So I'm not expecting you to be able to do this by the end of today. But I want you to know the reason why I'm doing this is because this all started with me knowing the units of my answer and being able to use one of these rates to plug in here to help cancel out my units and get my units right. Okay? So looking over here, we have a problem that looks very much the same. It says Joshua goes online to iTunes to buy some new songs to play at his party next weekend. The price is $1.50 for one song. So far, everything is exactly the same. Okay? Nothing is different here. However, it says if he has $24 to spend on his songs, how many songs can he buy? So we see that this is going to be a little bit different problem. It says how many songs can he buy? Our answer sentence should be he will buy blank songs. So, looking at this, again, I see the same rate in the problem, $1.50 for one song. So I'm going to write that both ways, $1.50 for one song. Or I could write that as one song is $1.50.
Can't you just divide 150 by 1?
So Judea is saying, if I want to solve this problem, I feel like I already know that I should be dividing here. So we're going to use the dimensional analysis to prove that that's true. I know my answer is supposed to be in songs. I know that I'm given $24. So I start with $24, but I need to change that $24 to a number of songs. This time, instead of using this first rate, I see that if I want to cancel out dollars and end up with songs on top, I need to use this rate. One song over $1.50. As I cancel out my units, dollars cancels out with dollars. I'm left with songs as my unit, 24 on top, and $1.50 on bottom, which leads us to prove that this is indeed, instead of a multiplication like the last problem, this one is a division. And so these were problems that many of you were able to sort out all on your own. You knew just by kind of looking at the problem, and because you have some background with these types of problems, or you've seen these problems or encountered these types of things in the real world, you knew what to do. You knew whether you were supposed to multiply or divide. However, there are going to be a lot of problems where it's just not as clear. And so this dimensional analysis is an excellent process to check your work along the way and help you inform you as to what you're supposed to be doing in a problem. Okay? So again, we don't need to be able to do this today. However, I want you to understand that it's the units from the answer. That's where we always start. And then we choose one of these rates that we've written, okay? So our key point here is that the reason why we're writing the rate both ways is because in different problems, we may need the rate different ways. And to prove that to you, in these first two problems that we've done, we had the same given rate both times, $1.50 for one song, but in the two different problems, I used it differently. One of them I used the $1.50 for one song, the other one I used the one song for $1.50. Okay? So that's why we are writing our rates two different ways. So we will be ready to use this dimensional analysis later on this week when we're ready for it. And you'll also see that we're focusing in on the units of our answer because we're also going to be using those two things to ground us in our work. All right? So what we're going to look at here is I'm going to go through one more problem with you where I'm pretty much leading the way. Then I'm going to have you guys do a couple problems where you're going to do it with your partner and check back in with me. And then you guys will have your regular together time, okay? So looking at this problem, it says the Radia family plans to drive to their vacation destination in 2 days. On day 1, the family travels 324 miles in 4.5 hours. If they drive at the same rate on day 2, and I recognize that word rate as I'm reading, so I'm underlining that for myself because I think that's a key word. It says, how many hours will it take the family to complete the 576-mile trip? So here's my question. It says, how many hours will it take? And I'm going to stop there at how many hours will it take, because that's enough information from this question for me to be able to write a complete answer sentence. How many hours will it take? It will take blank hours. Oops, I forgot my word take there. It will take blank hours. So again, making sure that we have the units on those answers, because we see when we're doing these problems later, that's going to be our starting point, the units on those answers. All right. In the problem, I'm looking for, since I think this is a rate problem, I saw that word rate in the middle there, I'm looking for a relationship between two different sets of units. As I'm scanning through, I see 576 miles. That really doesn't seem to have to do with anything. 2 days, that kind of has something to do with how long it's going to take them, but it looks like my true rate here is my true relationship is that it takes 4.5 hours to drive 324 miles. So I'm going to write that rate both ways. And that's as far as I'm going to ask you to go today. I'm going to do this one last problem with the dimensional analysis just so you can again see where we're going with this. So I'm using the units of my answer because I know that's my answer. I know that I'm trying to go 576 miles. And so if I want my units to cancel out, I'm going to use this rate here with the 324 miles because I need to get rid of those miles and get my hours on top. And so for this problem, we actually see that there's some multiplication that has to happen on top and some division that has to happen as well. Okay? So that's just looking forward to where we're going with this. Key thing here today, though, is that we can make sure that we can get these rates found in the word problem and we can pull them out and write them both ways. All right? What I'm going to ask you to do is I'm going to ask you to flip on over to your together time. The first 3 problems actually say teacher time. I'm going to give you 2 minutes to do the first problem. Then we'll check in. Then I'll give you 2 minutes to do the second problem. Then we'll check in. Then I'll give you about a minute to do the third problem because it's pretty quick. Then we'll check in. Then you'll have your regular together time for the rest of the time. Kyrie, what did you bracket as your question?
What is the actual distance between cities?
Excellent. What did you write as your complete answer sentence, Maria? The actual distance between cities is blank kilometers. And I'm really glad she made sure that she put her units on there. And also glad that she chose the correct units here, because remember, if we're thinking about the actual distance between cities, we're not going to be measuring in centimeters. We're going to be measuring in kilometers, all right? Was there anything that you underlined to identify this as a possible rate problem? Kyrie?
I chose as a rate.
And where did you read? Read for me what you boxed in was the given rate, Emmanuel. What did you box in the word problem that was the given rate? Read it for me, please.
The given rate is 12.7.
So remember that rates have to be a relationship between two different things. So 12 centimeters would be a singular thing. So for that to be part of our rate, we would need it to find a clear link between that and something else in this problem. Carson, what is the rate in this problem? Okay, so he reads right here, 4.5 centimeters is equivalent to 75 kilometers. In your work, you should be boxing in where that rate comes from. So 4.5 centimeters for 75 kilometers. Or, remember it can be written both ways. For every 75 kilometers, that's going to be 4.5 centimeters on the map. Okay. Okay, let's look at this second one. Iron, what did you box in as the question? Or bracket, excuse me.
I bracket how far will the spring stretch if a 12-pound weight is applied.
Okay, you can stop at how far will a spring stretch. And Kevin, what did you write as the complete answer sentence?
It will stretch like inches.
It will stretch blank inches. Really glad he got his units on there. What did you box in the problem as the given rate? Read for me in the problem where you got the given rate from. Leslie.
7
So from the problem, this is actually this long thing here. We should have underlined the words varies directly with. That's what should have indicated to us that this was a rate problem. And then we find the rate itself, which is 7 pounds for every 24.5 inches. We also could write that the other way.
Okay, the Bad Bros Club part number 2.
All right, and I'm going to give you about 1 minute for this last problem. Okay, so looking at this, you should have recognized the word for in here between these two different sets of units as identifying your rate. So you should have $500 for every 2 hours or 20 hours for every $500. Bracketed in your question here, how many hours must Sam work? And your complete answer sentence, he must work blank hours. Any questions about that? All right, as you flip